sorry about that. So it's 1, 2, root 3. And of course 60 lies here. Okay. So if you got cos, so if you got cos of a half, cos is adjacent of hypotenuse. So it's going to be 60 degrees. Okay. So my reference, angle x is equal to 60 degrees. So the question that comes to mind is which quadrant is cos negative? It's quadrant 1 and 2 and 3. So if you go with quadrant 2, it's going to be x is equal to, how do we get in quadrant 2 is 180 minus, so it's 180, so it's 180 minus theta. So it's 180 minus 60, which is 120, plus k times 360. Or in quadrant 3, x is equal to 180 plus 60, which is 240 plus k times 360. Where k is an element of integer. Normally we just write that once, then it would have been enough. Like I've written it there already, so I didn't really need to repeat it here. Okay? So once in the sum is suffice. Alright? Any confusion here? No? So now we're looking at example 2, and example 2 is on page, I think it's on the same page, no? Example 2 on page 106. Alright. So again it says solve for x if 3 sine x is equal to 1 plus cos 2x. And x is greater than or equal to negative 180 but less than or equal to 360. So here we got a restricted domain here. Or we got an interval for which the solution was lie between. So as I always do it, I first work out general solution and then I go to the interval. Okay? So what can be done here is, the only thing that we can do is we can change cos of 2x. So cos of 2x can be written as 1 of 3. 2 cos squared x minus 1, 1 minus 2 sine squared x, and x or alpha, and then cos squared alpha minus sine squared alpha. Okay, suppose we have been x or so. Alright, so which one of the three do you think I'm going to use? The one dealing with sine. Why? Because there is a sine. If there are going to be 3 cos, then I would have chosen cos. Can you see that? If this was sine x, cos x, then I would have chosen cos squared x minus sine squared x. Because it was a trinomial that needs to be factorized in. Does it make sense, people? Okay, so in this case I'm going to go with sine. Alright, so that's simply going to read 3 sine x equals 1 plus 1 minus 2 sine squared x. Alright, so we take everything to one side because that's a trinomial. So it's 2 sine squared x plus 3 sine x minus 2. Okay? Equals 0. So for those of you who can't see a trinomial, you should see, then replace sine with an x. So it's 2 sine x plus 3 x minus 2 equals 0. Remember, we're replacing sine x with an x. So this is a trinomial. If you don't know how to factorize this, use the quadratic formula. So it's 2x, x2 is 4, 1. So that's going to be plus and minus. Okay. If you had gone to the quadratic formula, you would have gotten x to be half and x to be negative 2. Then from there you go straight and say that sine of x equal to half and sine of x equal to negative 2. You can do that as well. No? Otherwise, if you see the trinomial here, we just say 2 sine x minus 1 and sine x plus 2. Okay. So now again, this is already factorized for us. So what do we say now? That sine of x is equal to half, or sine of x is equal to negative 2. As I said, if you use the quadratic formula, you would have come straight to that solution. You don't need to show that the factors in the in the brackets there. Okay? Let's pull this down a bit. So what do I say now? We take our reference angle. So reference x is equal to, and everybody knows that sine of x is equal to half. That means you say x is 30 degrees. Okay? So what comes to mind, people? In which quadrant is sine? Positive. In quadrant 1 and 2. How do I get in quadrant 1? Just the angle. So x is equal to 30 plus k times 360. Or, how do we get in quadrant 2? It's 180 minus, so x is equal to 180 minus 30 plus k times 360. So it's going to be 150 degrees plus k times 360. Okay. Otherwise, on the other hand, sine of x is equal to negative 2. If I work out this reference angle here, reference x is equal to arctan of 2, you will see you will have no solution. Not so. So what we do is, we just put a line through there. Okay. So that one is no solution for that branch, for that factor. So, okay. Any confusion, people? You all understand, eh? Right. So basically, the only grade 12 step in this case is the first one. Once we have gotten this sorted out, once you got that sorted, the rest is all grade 11 work. Can you see that? It's all grade 11 that comes into play. If I look at the first one as well, if I look here, if that was given in grade 11, you should have been able to do this part of the sum. Okay? However, the only grade 12 step in the sum is getting from there to there. The rest is all grade 11 work. Okay? So please do not forget to revise your grade 11 work. It's of utmost importance. Okay? We're looking at example 3, and example 3 is on the same page, correct? Right. Example 3. Alright, so here we are told find the general solution of the equation. 2 cos x is equal to sine x plus 30. Just coming back here, here was a restricted domain and the sum. However, that one wasn't. Okay. So I didn't answer this part of the question. Okay. So now we're looking at the solution that's lying between negative 180 and 360. Okay. Let's put this down here. So for x is for x being greater than or equal to negative 180 but less than or equal to 360 degrees, we now say x is an element of. We start listing. So remember that branch this branch here doesn't exist, so we don't have to worry about it. Okay, there's no solution. However, on this one, I start with k is 0. Not so? If k is 0, I'm left with 150. If k is 1, then it's going to be 150 plus 360, which is 4,510, which is outside this given domain. Can you see that? Then I do, if 1 doesn't work, of course 2 won't work, 3 won't work, and so on. So I try now negative 1. If I substitute negative 1, what do I get? Negative 210, is that correct? And if I go with negative 2, you will also see that that doesn't exist. Okay, let me just check. So it's 150 plus negative 1 times 360. Negative 1 times 360 give me negative 120, but if I made that negative 2, then you will see negative 570, which is outside the given domain. Okay, so I don't have to write that one down as well. Okay. Let's carry on. Okay. So example 3 on page 106, we are told find the general solution. Again, we got 2 cos x plus equals sine x plus 30 degrees. Okay. So what can be done here? Expand sine x plus 30. Alright, so you'll have then 2 cos x equals, the sine expansion is going to be sine alpha cos beta plus sine beta cos alpha. Okay. So we know that those are special angles there. So cos of 30 is root 3 over 2. Sine x plus sine 30 is half cos x is equal to 2 cos x. Okay. So as you can see, it's not a squared quadratic equation. So what I do is I take like terms to one side and on the other side constants. So in this case the other like terms. Okay. So you will have 2 cos x minus half cos x, which is going to give you 3 over 2 cos x is equal to root 3 over 2 sine x. So what do you think we're going to do now? We know that sine over cos is tan. So what I'm going to do is I'm going to divide both sides by cos x. Okay, so you divide both sides by cos x. That cancels, of course. No, that actually gives us tan x. The other side cancels. Okay, so this is actually tan x. So I'll have tan there. And the root 3 over 2 is equal to, that cancels, 3 over 2. So to get tan on its own, I'm going to divide both sides by root 3 over 2. Okay? And divide both sides by root 3 over 2. Okay? So that cancels. So tan x is equal to 3 over root 3. Okay. So that is the same as saying root 3 over 1 if I rationalize the denominator. Okay. So which triangle uses root 3? Is a 30 and 60 triangle. So that is 1, 2, root 3. So tan of what is going to give you root 3 over 1? So if I say 30, tan of 30 is 1 over root 3. Can you see that? Whilst tan of 60 is going to be root 3 over 1. So it's 60 degrees. And that is how I now know that my reference x is equal to 60 degrees. Okay? You all okay with that? So what was the question? The question was, find a general solution. So which question comes to mind? In which quadrant is tan positive? So tan is positive in 1 and 3. But remember, okay, so it's 1 and 3. Before I tell you now what to remember. So how do we get in quadrant 1? It's just the angle. So x is equal to 60 plus k times 180. Remember the period on the tan graph is 180. Or in quadrant 3, which is x is equal to 180 plus 60, which is 240, plus k times 180. Okay. Where k is an element of integers. Okay. K is an element of integers. But remember, we always told you that for tan, it's a repeated solution. So you don't need to write this. Okay. So you can leave that branch out. Okay. You don't have to represent it in that quadrant. Okay. Because why the second branch is a repeated solution of the first. Because why if you say k is 1 here, then it's going to be 60 plus 1 times 180, which is 240, which is also that first solution that we'll pick up here. Okay, so for tan, we only put it in quadrant 1 or quadrant 2. Okay, 3 and 4 will automatically fit into what we have already calculated. Okay, so the next one here, which is example 4, and example 4 is on page 107. Okay. In example 4, we are told that 3 sine x squared minus cos 2x minus cos squared x is equal to 0, where x is greater than or equal to 0, but less than or equal to 360. Again, so we got the restricted domain there, or given interval. Alright, so what can we do first? Sine 2x. So sine 2x can be written as what? 2 sine x cos x. So it's 2 sine x cos x. Minus cos squared x is equal to 0. So again, if you can't see a trinomial here, okay, then you replace sine with an x and a cos with a y. Okay, and then you factorize your trinomial, which is going to give me 3x, x, y, and y, and then the bigger product must be negative and positive. Okay. So in that case, it would have been 3 sine x plus cos x, and then you have sine x minus cos x. Okay. So now we can say that now we can say that 3 sine x plus cos x equal to 0. So 3 sine x is equal to negative cos x. You apply the 0 factor rule. So sine over cos is tan. So we divide by 3 as well both sides. So that is going to give us tan. X is equal to negative a third. Okay? Or we have we get over the equal sign. So sine x minus cos x is equal to 0. So sine x is equal to cos x. Divide both sides by cos, because we know that sine over x, sine x over cos x, of course, tan x. So tan x is equal to 1. Okay, so this is still without the use of a calculator rule here. But for this part of the calculation, definitely calculator needs to be applied. Okay, we need to use a calculator then. So let's go with the first one. The question that comes to mind is which quadrant is tan? Negative. So in which quadrant is tan negative? Quadrant 2 and 4. But we just represent it in one quadrant. Okay? So we say reference x is equal to arctan of a third. Arctan shift tan of a third is 18.43. 18.43. So in quadrant 2, we're going to say x is equal to 180 minus 18.43 plus k times 180. So we say 180 minus that answer. 180 minus that answer. It was 161,57. 161,57 plus k times 180. Okay. Again, we don't need to represent it in the fourth quadrant because that's again a repeated solution. Here we go here, our reference x angle here is going to be 45 degrees, also coming from that special triangle. 45 is 1, 1, root 2. Okay. So that would give us, the question that comes to mind, which quadrant will stand positive. So is it positive in one end? Quadrant 3. Again, we don't need to represent it in quadrant 3. Otherwise, we'll repeat its solution there. So x is equal to 45 degrees plus k times 180. And remember, k is an element of integers. Now coming back to the restriction, your angle has to lie between that given angle of 0 to 360 degrees. So with that in mind, we have to list. So we say x is an element of, it belongs to the set of. We'll start at, remember, 0 to 360. So if I go with k is 0, so I'll get 161,57. So what I do now is, if I see a k, I put a 1. So it's 161,57 plus 1 times 180 gives me an angle of 341,57. 341,57 degrees. And remember that that is still within this given interval here. Alright? Now we go to the other branch. If I put 0 by k, I'm going to get 45 degrees. If I'm going to put 1 by k, I'm going to get 225 degrees. If I'm going to put 2 by k, it's going to be 360 plus 45, which is 405 degrees, which is outside. Okay? If I'm going to put negative 1 in there, I'm going to get negative 135, which is below that given interval. Okay? People, it's very important to understand this here because it's worth a lot of marks in your exam. Okay? So with that, you should be able to do exercise 7. Alright.